Welcome to my video on the top 5 things I love about C# 7.0. At the time of this recording, Visual Studio 2017 has been out for about a month now, and I've had some time to play around with it. With the new version of Visual Studio comes a new version of C#. I've looked through all the changes they've made, and I've identified 5 things that I think are truly amazing new features. Today, I'm going to tell you what these 5 are and show you how to use them. So let's jump right in. The first thing I love is Inline Out Variables. Now, if you're not familiar with what an out variable is, essentially what happens is you have a method, like this try parse here, that wants to return 2 values. In this case, it returns a Boolean to tell us if it worked or not, and an age value, that's the out variable, the age value, if it did work. So we have a age text, which is some sort of string, and we've said, okay, we want to convert this over to an integer. But we're doing a try parse because what if in the text, instead of saying, 10, it was ten? Well, ten is not really a number. It represents a number, but it's not a number. And so if this value is ten, that's not a valid age. And if you're doing int.parse, that invalid age would crash the application. But in this case, the try parse, it says, did it work? Yes or no. And that's the isValidAge variable. That holds that then. And if it did work, the age parameter would get that value. But here's the really clunky thing about this. We have to declare an int age, but yet whatever value we have in here, in this case we've initialized it to 0, whatever value is in here gets overwritten by this out age. So you have a declaration here and an actual use or a assignment here. And it's fine, it's what we've done, but really it's a little bit clunky. So now this does work, so let's just show this real quick. So if I say 10, it says your age is 10. Now, if I run it again and type in ten, it says your age is 0. Why 0? That's the default. Now, if we had checked the isValidAge, we would have found that second value was not a valid age. But let's try a new way of doing things. So I'll comment this out, and I will uncomment these lines. All right. So this is the same thing as up here, except that we have the inline out variable. So you have out int age. See, that age is declared right in line. Now we can still use that age value in our scope because it's actually declared in this scope, inside these curly braces, not inside of this method. Now it may seem like a small thing to have this declared in line, but it does save a line up here, and it's a clunky line to begin with. Especially since you could say, well, if I made the default value to be 8, I would expect it to be 8 if it was not a valid age, but it's not. It'll be 0 again. So it's just a little clunky. The declaration inline just makes it a little more streamlined and smooth. So that's my first thing that I love. And it's, again, a small thing, but small things really add up when you're creating code. So declaration inline. And again, if you hadn't noticed how you do that, instead of saying out age, you say out int age, or whatever the type is that you're returning. And that right there is the declaration of the variable, and the out will handle the assignment. All right, so that's love number 1. Let's comment those back out. We'll go to love number 2. Love number 2 is pattern matching. And this is an interesting one. So let's uncomment this. So what I have here is I have a string that I called age from console. In quotes, it says 21. And then I have age from database, but it's an int type. So what this is representing here is the idea that maybe you're pulling a value right from the console, in which case it's a string, but maybe you already have it stored and it comes from the database, therefore an int. Both represent an age, but one is a string and one's a number. Now, what if we put one of those values, in this case we're going to pull the age from console, and put it into an object called ageVal. Now, an object can hold any type. So here we're going to say, what is that age value? So we say if age value is int age. So this pattern matching says, is this object actually an integer? If it is, put the value into this newly declared age variable. Now it gets even more fun in that we have this OR here. Now this is not part of pattern matching, this is kind of just adding pattern matching together. So this is right here is pattern matching. If an object is int age, and it doesn't have to be an object, it could be a class type, it could be an interface, whatever you want. If it is a int or whatever type you want to give it, if it is that, put it in age. But in our case, we have this OR. Now we know that age from console is not an integer, therefore we will not populate the age variable. But we have another option. We have this OR ageVal is, that's another pattern matching, string. If it is a string, put that value into age text. Now we have this AND as well. So if it's a string, this is true. But I have this AND here, so this has to be true and this has to be true. And what's this side? int.tryParse. Remember tryParse returns a true or false? And we say age text, which we just got from is string age text. So it takes that value and tries to parse it as an integer and sends it out to age, which is declared where? Right over here. So it says if the age text, or if the age value is a string, put it in age text, parse that, send it out as age. And then if this works, tryParse returns true. Therefore, this whole thing is true if it's a string that has a number in it. So if it's a number, or if it's a string that has a number in it, either one is true, then it goes down here and says your age is age. Now, that may be a little bit confusing, and this is a little more of an advanced example. But what we're doing here is saying, you pass in a number, I'll put that right in age. You pass in a string, I'll parse it and put it into age. We run this, it says your age is 21. 21 was inside quotes. Now it's not, now it's an actual number because age is an integer. Let's change this to be from the database instead. Let's run it again. Your age is 84. So this time I didn't have to do all this stuff. It did just this. So that pattern matching can be really powerful. And I want to show you a little more of a powerful example because sometimes the simple examples don't really show you the reason why you'd ever want to use it. I mean, checking to see if it's an int, that's kind of cool, but it might not be the most useful thing. Handling a number or a number inside of a string, that's a little more powerful. So that's my love number 2, the pattern matching. We'll actually see a little more of this coming up. Number 3 is my finally one. Love number 3 is their powerful switch statements. Now, switch has been kind of underutilized inside of C#, but for good reason. Switch hasn't really done a whole lot or been that valuable. It made a lot more sense to do an if, else, else instead, because you had a lot more power and flexibility there. Now, I think we'll see more people switching to using, well, switch, because there's a lot of power here as well. It at least gives it a little more option, a little better option for a use case for using switch. So let's look at what I have here. And let me just say right off the bat that this isn't great code. So don't copy this code as, ooh, this is awesome code. This is example code. So I'm going to get that out of the way right now. I use object. I don't use object hardly at all in my code. Practically never. But in this case, it makes sense because it makes it a little easier to show the true power of these examples. So here I have an employee, and let's look at this. Employee is first name, last name, is manager, and years worked. And then I have customer. And customer is first name, last name, and total dollars spent. So those are the two types I have, and I've created two of each. So I have an employee called Joe Smith. He is not a manager. And I have an employee called Sandra Jones, and she is a manager. Then I have customer 1, which is Tim Corey, and I've spent over $2,000. Whereas customer 2, Delanna Greenback, has spent $558. In case you're wondering, the M on the end is for a decimal constant. If I didn't have the M on the end, it would think it's a double. And so it'd have to do a conversion which won't work. And so you have to specify, no, this constant is actually a type decimal. Just think M for money. Now I've taken these 4 objects and I have put them into the list of object called people. So people is a list of object, therefore it can hold both employees and customers. And I have passed in employee 1 to customer 1, customer 2. So now let's pretend that later on in the application, I want to loop through people. And I want to use the objects. But the problem is that I can't just say p.firstname because maybe not all the objects have a first name. So for example, if I went down here, I said p dot, I get nothing because it treats it as an object. It doesn't know that it's an employee or a customer. So we can do a switch statement. And the switch statement has some really powerful pattern matching. Instead of just saying it has to be equal to something, now we're doing this pattern match where we say employee E. So essentially it's saying if P is an employee, and if it is, put it inside E. But then I got this when statement. So if it's an employee, put it in E, when E dot is manager equals false. So what it's saying is, if it's an employee and the is manager property of that employee object is false, then say E.firstname is a good employee. And these are just kind of tags to let us know which one of these case statements ran. So that's the first case. The second case is employee E when E.isManager, meaning essentially isManager equals true. And it says first name runs this company because you only have one manager in my fictitious example. But then we have case customer C when C.total dollars spent is greater than 1,000. So essentially a big spender. C.firstname is a loyal customer. And the last statement I have is just customer C. Essentially just match on this customer C. And therefore we'll say C.firstname needs to spend more money. Now that raises an interesting point. Customer C would match both Delanna and Tim. But Now with switch statements, and this wasn't always the case, but now with switch statements, order is important. Therefore, if it's a customer and total dollars spent is greater than 1,000, this one will be run. Otherwise, it will continue on. Therefore, this one will only capture customers who have not spent more than $1,000. So ordering is important. We have the pattern matching, and we have this when statement that allows us to have this Boolean true or false return value to find out any kind of comparison you want. So we can add one here where E dot years worked is greater than 10, and only Sandra Jones would apply for that. So there's a lot of things we can do here in our switch statement to kind of dial into exactly what we want to see. And we have this ordering here that's important, so we can actually sort of filter out the ones that don't match in order to find the final one that does, or the first one that does. So that's my love number 3, is finally they've upgraded the switch statement and given it a little more power, or a lot more power. Number 4. This is an interesting one. And it's one you may not have thought about. So here I've got, as setup, I just create a new list of employee and took those same 2 employees from above and put them into people. So now what I'm going to do is find the CEO. And I said the CEO is the first person that has is manager set to true. Now, you've probably seen this before. People.where x lambda expression x.isManager. Essentially saying who has the isManager flag set to true. But that returns a list, a where returns an IEnumerable of the type employee. So I said first or default. Now the problem with this is if it doesn't find one, first or default returns a null value. That would crash this right here. CEO.firstname. CEO.firstname of a null value for CEO crashes the application. In fact, we can demonstrate that here by just putting the semicolon right here, commenting the rest out. And now let's run this. The CEO is Sandra. That's great because we actually have a manager. But what if the manager goes away? It crashes the application, object reference not set to an instance of an object. And that's not a great error message. So let's take this code and put it back. And we have the null coalescing operator. Now, a null coalescing operator, what it does is it says if this value right here is not null, use that value. Otherwise, use this value. But notice this value over here says throw new exception. Well, what it's saying is if you don't find a person, don't just blindly put null in a CEO. Throw an exception, but throw one of our choosing. In this case, there's a problem finding a manager. Let's run this. We have an exception, but the exception, instead of saying object reference not set to an instance of an object, it says there's a problem finding a manager. A lot more clear. So what's the benefit here? Well, here we can throw exceptions inside of expressions. So right in line here, we can throw an exception. We don't have to, and see, here's the way you would do it. You would come over here and you'd say, if CEO equals null, then throw this new exception. I'll just copy this and paste it. And then you'd run this again. We get that nice error message, but notice we have an extra 3 lines of code when I essentially can do the same thing. And let's delete this out. We can do the same thing by just adding this null coalescing operator and saying throw new exception right in line. So that's a nice feature, at least for me. And maybe you say, you know what, I'll probably never use that, and that's fine. But there's times, and it's not often, but there are times when you're working with lists especially, and that's why I demonstrated a list, where this first default comes up, and you're like, yeah, but you really have to have a value. You can't have a null. And so instead of just trusting blindly or putting that if statement in there for checking, you can just do it right away in line and say, hey, just throw an exception if you don't find something. So that can be really helpful. All right, so that's number 4. One more to go. Number 5 is my favorite by far. Tuples. Now, tuples is a programming specific term, at least in my mind. I'm not sure that it's used anywhere else in the world. But tuples, what it essentially means is an object with multiple values. And so the idea is we can return more than one return value on a method. So remember way back up here, let's look, we had this int.tryParse. And tryParse want to return a Boolean for it worked or it didn't work, and it wanted to return age. And we had to use this out variable. And it's a little ugly and a little clunky, but it works. And we have now the inline, which is so much more awesome. But tuple solves that in a different way by saying, you know what? Return 2 values, or 3, or 4, or 5. Now you could say, well, you can create a class object and return an instance of that object, and that's true. But sometimes you don't need to create an instance of an object to just return a couple of values. In this case, we have split name. Now again, not great code. So many ways it could fail. You shouldn't copy this code itself. But the idea behind it works really well. So we're passing in a full name. I want to get back first name and last name in separate variables. So I split on the space and I return value 0 and value 1 with commas in between, surrounded by these parens. And so now I've returned 2 values. Now I could just say string comma string. I don't have to name them. But I would say for a best practice, name them. It's kind of like giving your variables the X and Y and Z. That works for really short things like for loops, but you really shouldn't do that for actual applications, especially not for returning values from a method. So give it a name here. So string first name, string last name. Now I can use this. Notice up here, split name. I pass in Tim Corey, and I put into var name. Now I don't have to put in a var. I could say string, well, if I can type it right. String first name, string last name, like so. And that would work. That's a lot of typing. Var does the same thing. If you mouse over it, you'll notice that it says string first name, string last name. So it still has that. It's still strongly typed. It's just var is so much easier to type. So now I can say the first name is name, that's our variable, dot first name. And the last name is name dot last name. And that's really all there is to it. If we run this, we'll see that my first name is Tim and my last name is Corey. So it works. If you want to return 3 values from this, you could say bool it worked. And then you just return back a true or false. Let's just return back true just to show that we can do something. And we'll actually just put a breakpoint right here. and run this, we can see that name now has 3 values, Tim, Corey, and true, for it worked. So we can pass back multiple values in different ways, as many as you want really, although I wouldn't go crazy with it. If you really have to return a ton of values, maybe you might want to rethink how you're doing things. Maybe passing a class back and forth is the right way of doing things, or class instance. So at Tuples really is that shortcut for when you just need to pass back 2 values or 3 values. Something simple, something quick. It doesn't have to be as complicated, convoluted, multi-form, multi-step process to return these 2 values. You just want to return 2 values. Therefore, the tuple is the way to go. So that's my top 5 things I love about C# 7.0. Now there's some things I haven't mentioned because, quite frankly, I didn't love them as much. Okay, you can do things like using an underscore and a number constant in order to separate the values. I just don't care. Okay, and part of that has to do with the fact that I don't use that very much. I don't use large number constants where I have to understand what they are. So it's really up to you if you think those are as valuable as well. So I'd love to hear from you what you think you'd want to add to this top 5 or take away from this top 5. So leave a comment down below with what your favorite thing is, as well as what your maybe least favorite thing is. And while you're at it, I just want to point out a couple things. First of all, I'd really appreciate if you'd subscribe. That really helps me out. And also, if you would hit the thumbs up in this video if you appreciate it and liked it. And hey, if you didn't like it, if you hated it, go ahead and hit a thumbs down. Let me know. Or leave a comment. That's really constructive. My videos change based upon your feedback. So that's it. I appreciate it. Thanks for watching, and stick around for the next video.